equals. So in section P.1, it's the very first, there's a chapter P. It's kind of like an introductory chapter, like a preview chapter. I'll sit down probably so they can see behind me. Okay, so in the first section P.1, there will be some problems that are easier that you guys are gonna you're gonna be like, okay, I already know that, I got that. And then there'll be a couple things that you might not have heard about before. So some of the things in this chapter, they start using formulas, which I know you've seen before. Like the formula T equals negative x squared plus 361x plus 3,193. They might have some bigger problems, like bigger numbers in the problems. So they're going to use some formulas in this section. This formula, T equals negative x squared plus 361x plus 3,193 models the average cost of tuition for college. For X years after the year 2000, after 2000. Okay, so I know you've seen formulas before, and it's just a matter of like knowing what to do and knowing what the letters stand for. So at the end they said X years. See, the X in the problem stands for years. X years after 2000. So then they'll tell you to find something. Find the average cost of tuition for the year 2020, 2020. Find the average cost. Find average cost of tuition for the year 2020. So what do you think? They give you a formula, and you have to know what to do with the formula. Anyone have an idea of what to do? Yeah, you have to know that X was the years, and up here it said the formula stands for years after 2000. So you have to think, how many years after 2000 is it now? Now they're saying it's 2020, 2020. So you're right, you have to plug in X is 20. That's how you do this problem. You're going to have to plug in X is 20 up above, up in that formula they gave you. All right, so the thing to watch out for that some students make a mistake about is there's a negative sign at the beginning of that formula. It has negative, and then we're going to plug in 20 squared plus 361 times 20 plus 3,193. The thing that students mess up sometimes is the negative. The negative is like in the very front. You just have to take 20 and square it. You don't have to take negative 20 and square it. The negative's in the front. It's separate. And so some students mess that up. That's why I'm pointing it out. You just take 20 and square it. 20 squared is 400. Then you bring that negative down. It goes in front of it. It's not negative 20 squared. It's just 20 squared. Then put the negative in front. So you got to watch for that. That's the only thing I think that would have messed a few of you up if you were doing this on your own, like on an assignment or on a test, the negative sign. And then, yeah, you need the calculator to kind of do the rest. 361 times 20 is 7,220 plus 3,193. And then add it up and you'll have the answer, right? Let's see what I got. 7220 plus 3193. Yeah, so you will need a calculator for this class. I got 10,013. What does that stand for? What do you think what does this mean? Because that was 20 years, so like what's this answer? Yeah, it's the cost of tuition. It's just like $10,000 for the cost of tuition. So that is money. You could put a dollar sign. That's the cost of tuition. So I think that kind of stuff will be familiar to you. Plugging in numbers into formulas, that's pretty simple. The next thing in chapter 1, in this chapter P, is intersection of sets. This might not be as familiar to you. It's really not too difficult though. It's not a hard concept, but it's just different. I don't think it wasn't covered in algebra 2. Intersection of sets. Okay, this is, you see these in math text sometimes, and they draw what's called a Venn diagram. They have like these circles that overlap. You've probably seen those before. So one circle represents set A, and the other circle is set B, and you can see they overlap. This is how you write intersection. They write this symbol. It's like a U, but it's upside down. It's like an arch. That says A intersected with B. Set A intersected with set B. That's how you would read that. A intersect B. What does that mean? It's the part inside of here where they might have something in common. That's all it is. Where they might have something in common. A intersect B is this section in the middle. A intersect B. So it's not a really difficult concept, but it's something you might not have seen in Algebra 2 class, obviously. So let's say that set A was the numbers 7, 8, 9, 10, and 11. So let's put it like in a mathematical terms. And then you're supposed to intersect that set of numbers with 6, 8, 10, 12. Sets are written with these like squiggly lines around them like that. And it's just like a set of numbers, like a group of numbers. So 7, 8, 9, 10, 11, that group of numbers, that could be like set A, intersected with 6, 8, 10, 12. So if you kind of understand what this picture means, you're looking for what they have in common. What do you think the answer is? Yeah, they have 10 in common. See the number 10? They both have 10 in those lists. What else? Yeah, 8 also. So the answer for this one would be 8 and 10. And they put it in a set, which is like those squiggly braces around it. Something they have in common is all that intersection is. Yep, so intersection is what two groups have in common. So I'm going to give you another list of numbers and see what you think of this one. Okay, so now I'm putting a set of numbers 2, 4, 6, and we're going to intersect it with this set over here, and it's going to be this set is 3, 5, 7. So 2, 4, and 6 intersect it with 3, 5, 7. What do you think this time? If they ask for intersection, you know what to put? Do they have anything in common? Okay, no. So you do this, it's easy. It's just like a no solution symbol. I think you've seen this symbol before. It means there's no answer. It's an empty set. They call that an empty set. It's just like no solution because they didn't have anything in common. Empty set. Another name for that is the null set. They sometimes empty set or null set. It just means like there's nothing common, no solution. So this might be a topic you haven't heard of before, intersection of sets. Unless if you took discrete math last year, or the last couple of years, some people took discrete, you do it in there. And then there's what's called a union of sets. Intersection we just did, now there's one called union of sets. And this goes A union B. It's just like a U in the middle, kind of. Don't bring the, you know how when you make a U, you bring this little line down on the side? Just the union symbol doesn't have that line going down the side. Just a curvy thing going up like that. A union B. Okay, A union B. If I draw it with those circles again, what are we looking for A union B? A union B, what you're looking for actually is everything. It's like putting both sets together. You want everything within this set and everything in the other set. It's like all of it put together. Yep, so union of sets is just like you want everything that's in set A and everything that's in set B for a union. So if we had set A was, I'll just do 7, 8, 9, 10, 11 again. Okay, so set A was 7, 8, 9, 10, 11, and then you're going to union it with another set. Union with 6, 8, 10, 12. What would we get? If they want you to do a union, do you know what the answer would be? Yep, everything. It'll be 6, 7, 8, 9, 10, 11, 12. Be all of it. Nope, you don't have to write things that repeat twice. Yep, you don't have to write repeating things because 8, yeah, 8's in both, so like 8 would have been like in the middle section, and you don't have to write it twice. They specifically actually say don't write it twice. Yeah, don't write repeats twice. Just make sure you wrote down all the numbers. 6, 7, 8, 9, 10, 11, 12. That's a union, like put it all together. So you just gotta know the difference. Intersection is what they have in common, just what's in the middle, just the common things. And union is all the everything. Everything in set A and everything in set B. But don't write the repeats. Yeah. It could be letters or anything you want. Yeah, I could draw a set. Like I could do a set on the board. I could do anything I wanted really, yeah. I could put like we could even put like food, like there's probably if there's me and somebody else in the room, like my husband, Tony, we both like pizza, so I'd put pizza in here. You know, something like that, like we both like this food. And then I like Brussels sprouts and he doesn't. So, you know, so it could even be like things. It doesn't just have to be numbers. Yeah. So I'll put Brussels sprouts. And he likes I don't know, I'm just making stuff up. He likes what's something gross that he might like that I don't. I can't think of anything. Oh yeah, he likes mushrooms. I don't really like mushrooms that much. I'll eat them, I guess, but I don't really like them that much. So yeah, it could be something like that. And then if you put it union together, it'd be like Brussels sprouts, pizza, and mushrooms. Yeah. Or if it's the intersection, we like pizza. We both like pizza. Yeah, it could be words, it could be letters. She was asking if it's only numbers. No, it could be letters like A, B, C, D, E, F, G, H, I. You know, it could be like anything like that. Yeah, it doesn't just have to be numbers. It could be letters, it could be items. Okay, so intersection and union, it's not too tough. It's not really tough. Okay, then the book, this section 1 also talks about the real number system. Real numbers. I know you guys have heard of this before, so it'll just be a quick review of it. They might give you on an assignment a whole list of numbers, and then you have to categorize them. They ask you, like, what kind of number is this? So there are natural numbers, whole numbers, integers. I know you've heard of this stuff before, so we'll just go over it really quick. Natural numbers, whole numbers, there's integers. For integers, they don't use an I because they use I for something else. So integers, they put a capital Z. And then there's rational numbers and irrational. Rational, they put a Q for that because real is R, so they have to use it. And rational is another R word, so they have to put a Q. And then irrational is I. It helps to have these abbreviations so you don't have to write the whole word out all the time. Yeah, thank you. We can look pretty soon. We'll do absolute value and then you can go up. Okay, so you've probably heard of these sets of numbers before. What do you guys know what the natural numbers are? Do you remember what the kind of numbers those are? Yeah, like positive numbers. Yep, like 1, 2, 3, 4, 5, etc. So I'm sure you guys have heard of those before. Do you remember what whole numbers were? Yeah, it also includes zeros, but it's still all the positives. It's 0 and 1, 2, 3, 4, etc. Integers are positives and negatives, right? So I'm going to go like 0, 1, 2, 3, dot, 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 and negative 1, negative 2, negative 3, dot, dot, dot. You know, it keeps going both ways. Yes, I'm sure you've heard of integers before. And so if I threw a number out there, like if I say the number 8, what kind of number is it? It can fit in more than one category. Like the number 8 is an integer, 8 is whole, 8 is natural. And all of these are real numbers. 8 is also a real number. Rational includes all of these above, plus any other numbers that you could write as fractions. Because you could write all of these as fractions. You could put 5 over 1 or 2 over 1. So rational is anything you can write as a fraction. Like 2/3 or point, I'll put like 0.3 repeating or 0.725. Rational numbers is anything you can write as a fraction. Even decimals, you can write this 0.3 as a fraction. 0.3 as a fraction, that's 1/3. It's 3 over 9, which is what reduces down to 1/3. 0.725, you could change that into a fraction. You could put 725, and this is in the tens, hundreds, thousands place, over 1,000. Yeah. So you can change these all, even decimals. You can, some of them you can change to fractions. But then the irrational ones are ones you can't write as fractions. They're like decimals that go on forever, like pi. Because we know pi is like 3.14159 dot 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 keeps going. Or square root of some numbers. If it was like square root of 2, I'll try that one. I'll just grab a calculator. Square root of 2 is about 1.414213 dot dot dot. It keeps going. It doesn't stop, and you can't write it as a fraction. Yeah. Repeating decimals, you can change them to fractions. You can put like 3 over 9. If it's like if it's point, oh, like if it's like 0.26 repeating. If it's repeating, you can put 2, 6. Oops, I can't write. you can put 26 over 99 and then you can reduce it. It's like with repeating ones, you can put them over 9 and then reduce them. Like 0.3 repeating, it's 3 over 9, and then you reduce it down to 1/3. Because if you divide 1 divided by 3, you get 0.3 repeating. Yep, the repeating decimals, yeah, that's the one. The repeating ones go in the rational category, and then decimals that just don't stop, they don't end, and they don't repeat go in the irrational category. So I'm sure you've seen some of that before, and like I said, when we start the assignment next class and start practicing these things, they'll give you a number, and you'll be like, okay, where does that go? Which category? And it can be in more than one category. Okay, then there's some absolute value stuff in this section also, in section 1. A lot of you have seen absolute value before. There's a formal definition of it in this text. Definition. There's absolute value. I'll put the definition down. Absolute value of x equals x if x is greater than or equal to 0, and it equals the opposite of x, or negative x, or I like to say opposite of x, if x is less than 0. Yeah, this negative, I like to say like opposite. It kind of means you have to change the sign. You know, because like absolute value, if you have absolute value of negative, you have to change it to positive. So you opposite or change it. And so I know you've seen absolute value before, but there's a couple tricky problems in here I'll show you. Like some of the easy ones are obviously pretty easy, like what's the absolute value of this number? 7. What's the absolute value of 7? Yeah, it's 7. So you can see like if the number in there is greater than, see this means greater than, if the number in there is greater than 0 or equal to 0, see 7 is bigger than 0, isn't it? Then it just stays the same number, it stays as x. But if the number in there is a negative number, like negative 8, then what do? If this x, the number in there, x, if it's less than 0, then what do? Yeah, you take the opposite of it, you switch it from negative 8, you switch it the opposite, you change it to positive 8. So that's why I put this in red. See, it's like thinking I gotta switch the sign, like opposite, flip the sign. So that's I know, like I said, I know you've seen absolute value before, but I don't know if you've seen these kinds that say rewrite. There's a few in the book that say rewrite without absolute value. Okay, this is kind of different. They'll say absolute value of square root of 3 minus 1, something like that. And the absolute value lines are around it. Those straight lines, that's the absolute value lines. So they just tell you, okay, it doesn't say solve, it just says rewrite it without the absolute value. Okay, so this is where this definition up here comes in, where you have to think, is it the top scenario in the definition, or is it the bottom situation? You know, that's why there's like these two lines in the definition. If whatever's in here is greater than or equal to 0, then it basically stays the same. But if the stuff in here, like this 8, this negative 8, that was less than 0, so I had to switch it. That's what you have to think when you do this. You have to think, well, okay, square root of 3 minus 1. Let's see what that is. Square root of 3. Yeah, see if you can see it. Square root of 3 minus 1. Square root of 3 minus 1 is 0.73. I don't want you to write 0.73. That's not the answer. It just said rewrite it without absolute value. It doesn't say solve, see? So the answer is not this, but I got 0.73. That tells me what scenario I have in the definition. Is 0.73, is that greater than 0 or less than 0? No, it's greater than 0. Because less than 0 would be negative things. Yeah. 0.73 is greater than 0, like 73 cents. That's more than nothing. So it's greater than 0. So I keep it the same. My answer is square root of 3 minus 1. That's the answer. I got 3, huh? So then if it said, what about this one? 2 minus pi. Okay, let's do that on my calculator. 2 minus pi. If I do 2 minus pi on my calculator, see, now I'm getting a negative. I'm getting something less than 0. So what do I want to do on this one? I want, if you take, pi is 3.14. If I did 2 minus 3.14, I'm getting like something negative. I'm getting something that's less than 0. So I want to flip it. I want to do the opposite. I want to do negative 2 minus pi. See, that one, this one comes out negative. This is less than 0. So you're going to want to do this part of the definition, the opposite. Yeah, you have to know. Yeah, you have to know if this is positive or negative. Oh, no. No, you don't just switch that to positive. If I think about this whole answer, is that positive or negative? So if this whole answer is negative, so then you switch it. So now it's going to be negative 2 plus pi. That's the answer. You switch the signs. You distribute the negative. Yeah. No, you could also write it as, that's the right answer, or pi minus 2 is another correct answer. Is that what you mean? Yeah, you could write it like this or this. So it's kind of, this is kind of weird because you're not solving it, you're not writing a decimal, but you're leaving it the same, or you switch the signs. Yeah. So you could write negative 2 plus pi for the final answer, or pi minus 2. Yes, that's a little different. We're almost done with the section 1. So you can this, you have to distribute the negative. Yeah, they want you to, their final answer, they distribute it. So you can either put negative 2 plus pi or pi minus 2. So there's a lot of stuff in this first lesson, as you can see, that we're going to be working on. Another thing is find the distance. But we'll have all our notes done today, and then next time we could just start working on these kind of things and practice it. Find the distance between negative 5 and 3 on the number line. Well, you could draw a number line and count it out. Some people can visualize it in their head, how far apart those are. Or you can use the concept of absolute value to do this. A distance is like a difference from point A to point B. Like you're traveling from one point to another. So a distance is a difference between these points. So to do this one, you just got to think of that. You have to know that distance is a difference. And difference in math means to subtract. Distance is a difference from point A to point B, like how far apart, what's the difference between here to here. So distance is a difference, so that means you're going to subtract. You're going to take negative 5 minus 3. So you actually subtract those numbers. But negative 5 minus 3 is a negative answer. It's a negative 8. So you use the concept of absolute value. How far apart are those points? Positive 8. So if you're talking in terms of distance, you can just subtract and use absolute value. You report the distance as like it's 8 units away from here to here. You don't say negative 8. That's why it's absolute value. You just take the absolute value and subtract. And then, I think I'm going too fast. People are still writing. Maybe. Okay, so yep, absolute value can help you with finding distance. You just subtract. And then one last final thing for a lesson P1, they'll have you do some simplifying problems. And I'll give you one that you guys could try. Kind of a review from algebra. And like I said, there's different levels of students in here. So some of you will easily be able to do this, and others are going to be like, wait, I forgot how to do this. So help each other out. You could kind of work at your table and see. Let's try to simplify this. I'm going to give you a couple minutes, see if you can do it. Some of you are going to be like, yep, whip through it. Some of you will be like, wait, what's the first step? Think for a minute or two. Parentheses. How you get rid of the parentheses. Yeah. Yeah. So she's going to be working on this week. It's like okay, the thing about this one's these parentheses and stuff, right? How to start it off. Yeah, this negative sign right here, you have to distribute that negative. So if you guys were looking at it going, wait, what do I do? You have to distribute the negative. That's right there in front. So it still says 8x. I'm still writing all the 8x and the 2 and the 5. Those don't change yet. So distribute, you get negative plus 3. Then you can do what? Add like terms, yeah. Like in here, you could add the 5 and the 3 together. So you'd have 8 minus x. Or some people, actually, it's okay if you distributed the 2 next and then added the like terms. You can do it that way too. Sometimes there's more than one way. So if you didn't add those, you did distribute 2 next, that's okay, and then add. It really wouldn't matter. You'll still get the same answer. Finally, distribute this 2, right? You get the 2, so you get 16 here minus 2x. And final answer? 6 plus 16. Yep. I think I had this class yesterday. Some of them forgot what to do at the beginning about that negative. That was the only thing that people were struggling with. Getting started on. And then lesson P2 is the lesson we'll show you a little bit too. I know you guys might think like, geez, why are we doing all this today? If we don't start, we're not going to get through 7 chapters a semester. So like I said, it's going to go kind of quick. You're going to our notes, our example stuff on today, then we can dive in next time and get going on the lesson. I'll probably do maybe like a note card, yeah, because they're asking that. Yeah, like a note card for this, like a note for notes. Maybe let you use like a note card. right microscope. Okay, to give you an idea of what this lesson is, the second lesson that we're going to work on, this I'll show you a few problems. This is not notes in section one. This lesson two like reviews a lot of exponents. So a couple problems down. You probably know some of these already. But I've been like one down in your notes, you're like, oh yeah, I remember those kinds. Okay, we'll put what this one equals, what this one equals. So lesson two in this is a lot of exponentials, reviewing them, and I bet you know how to do quite a few of these actually. Yeah. Okay, so the top problem says 6x to the fourth, y to the third, 5x squared, y to the seventh. Some of you probably already know how to do that. Do you know what to do? What do you put together? Yeah, these exponents are going to go together somehow. And what do you do with the 6 and the 5? Okay, so those are called coefficients. So you apply the coefficients together. That's the big numbers out front. So the 6 times 5 is 30, right? Then what do you do with the x and the y stuff? Yep, you add the exponents. So see, just quick review of that. So it'll be x to the y what? 10. Yeah, because there's a 3 and a 7. You got 3 plus is 10. And that would multiply and add your exponents. What about if you have a fraction? Yeah, divide the big numbers in front. 30 divided by 5 is 6. And you subtract the exponents. So x, what? 9, y2. And again, write a little note for yourself if you need to. Or if some of you already know this, like I said, there's different levels of people in here. If you don't, you're like, okay, I don't need to do that, I already knew that. Or some people think like, yes, I gotta write this down, that you divide efficient. You know, if you have to write it, like really, like write little notes for yourself. Oops, I spelled it wrong. C-E-N-T-S. That's sloppy. Divide your coefficients and subtract your exponents. Like write little notes for yourself if you need to. It's notes for you, but some people might be like, I don't need to write that, I got it. It's fine. Do what you need to do. Write what you need to write. What about stuff to the 0 power? Yeah, anything to the 0 power equals 1. Good job. So what is this problem going to equal? Some people said, okay, this one's kind of tricky actually. The 3, does the 3 have like a power up here by it? Going like 3 to the 0 power? Yeah, that's 3 to the first. So the only thing that's to the 0 power, right, is just this part. So the x 0 power, yes, that equals 1. So the answer is 3. Just the 3 is not 0 power. That's like 3 meters power. So that's it. Again, kind of get tricky. If it would have had parentheses around it like this, and then like that, 3x and the whole thing to the 0 power, then that would have been 1. It depends on how they write it. So you got to watch for parentheses. That's kind of a tricky one because this one actually 3. So like this would equal 1. Okay, what if we got b to the third over b to the fifth? Yeah, we talked about action 1 right here, and you said when you do the fraction, you said to subtract the exponents. So if I subtract 3 minus 5, I get negative 2. So how do you deal with a negative? Somebody over here said it. You have to put 1 over b. If you get a negative exponent, you can't leave it like that. You have to put it in the denominator. Or if you would have had like 1, if you would have had something over x to a negative power, like x to the negative third, then you can't leave it like that in a answer. Final answer, you can't have negative exponents. So what do you do with it? Something like that. Yeah, it would be the third. You would like bring it back up to the numerator, so it'd be like that 1. It's like a reciprocal thing. You flip. What else? See, so this section too is about exponents. What if you had? I'll do more. Okay, I'll do one more. You had x squared over 4, and then let's say the whole thing was to the negative third power. See, they get a little trickier as you go. What if you had x squared over 4 and then to the negative third power? So it's quotient. It's one of those divided ones, and it has raised to power. The power, this 3 power has kind of like, you have to take the power of the numerator and you have to put the power in the denominator too. So it was x squared, and then you have to take that negative third power, and then the bottom is 4 adding to the negative third power. So how do you do a power, something that already had a power and another power? How you multiply those powers? Parentheses, you multiply. Power of a power, you multiply. So that turns out to x to the negative 6 and 4 to the negative third. You can't keep it like that though. A final answer can't have negative exponents in it. Yeah, you flip it. It's a reciprocal to make that, so you don't have a negative 3 on that anymore. You put it at the top, and the x6 goes down here. You gotta get rid of the negatives. So you do a reciprocal, you flip it. And then finally, do you know what 4 to the third is? Yeah, so it ends up being 64 over x to the 6. Okay, so section 2 is, we covered section 1 and 2 today. We covered section 1 and 2. I know we have examples, then we'll be able to start working on it next time and start working on the problems on it. We got a lot, and hopefully the WIT Canvas by then. Like Lexi just checked and it's not on there. Oh yeah, sure. Oops, remove it. I moved everything. And we still got 10 minutes. There's a lot. Review. Times 4 times 4. 4 to the third power. Oh yeah. I'll double check it. Just make sure. Caitlin.